The charging and discharging current of the battery flows through the battery and part of the energy is consumed on its internal resistance. This energy is mainly converted into thermal energy and heats the battery. The power with which electrical energy is converted into thermal energy is the product of the value of the electric current squared and the internal resistance of the battery. P equals I2R. Electrical energy converted into heat in this case is not only a loss of energy, but stronger heating is very harmful to the battery and shortens its life. Due to this fact, the strength of the electric current when charging and discharging the battery must be limited. There is no strict limit up to which current strength we do not have a harmful effect of heat, and from which current strength we have a harmful effect of the generated heat. But 20% or 1/5 of the current specified for the battery capacity is taken as a referent point. Thus, a battery of 100 amp-hours can be charged and discharged with a current of less than 20 amps. Charging and discharging the battery with a stronger current than specified significantly damages the battery and shortens its life. When installing a battery in a device power supply system or a ship's electric propulsion system, it is necessary to know the maximum value of the current that will be drawn from the battery for a long period of time. So, for example, in the case of a ship with an electric propulsion of 10 kilowatts with a voltage of 48 volts, a referent current which would be drawn from the battery is 208 amps. Because this current of 208 amps is fifth part of the current noted in the capacity. The capacity needed for that is current multiplied by 5. Which gives us 1040 amp-hours. That capacity is needed for normal operation and long battery life. To obtain 48 volts and 1040 amp-hours, a number of batteries have to be connected in combinations of serial and parallel connections. Since every unit of the batteries has a voltage of 12 volts, it is needed to have 4 of them connected in serial connection. The capacity in serial connection of 4 batteries remains the same. 100 amp-hours. To obtain 1040 amp-hours, we have to connect that sets of serially connected batteries into parallel connections. If we connect 5 of that sets in parallel connection, we would get 1000 amp-hours. That is close to needed value but under it, and that is not acceptable solution. Parallel connections of 6 of that sets gives us 1200 amp-hours, which is acceptable. There are some of the technical rules in batteries connecting which are very important. Never connect batteries of different capacity and voltage into serial or parallel connection. Always connect only fully charged and equally old batteries. Connecting empty battery in parallel connection with fully charged battery is very dangerous and can cause explosion of both of them. When connecting batteries in parallel connection, the length and the thickness of the cables from every battery to the connecting point have to be the same.